Everyone today can go and take CERN open data, discover again and again Higgs boson. But the question is, can AI do the same? Can it orchestrate different steps that are needed? For example, here you can see there is this nice plot of the discovery, but the code itself still a bit complicated, right? There are a lot of stuff, a lot of steps that usually scientists does to select the physics subject to reconstruct what happens. Yeah, so the challenge today is taking GPTScript that is taught as a bash script for AI, if you want to put it in this way, taking a couple of parts of this analysis and telling him, yeah, can you do this for me? I give you an example of how I select muons, for example, time to time. Please take this as an example and apply when asked for. That's the idea. Let's see how it goes. All right, so first of all, we are going to take part of this code, right? So the steps that we want to enable GPTScript to understand and compose in this very first example are the following. So we are going to import the root, that is the software that will go and do the analysis, open the data files and so on and so forth. Tell him, okay, I want to enable the implicit multithreading and do this kind of prerequisites, right? So importing all the libraries that I need in order to do the following functions. Then I'm going ahead and tell GPTScript, well, I give you some example of all these functions here. And for instance, you see I gave you an example of how to select 4 good muons with all these best practices. Take inspiration from this and replicate what I taught you, right? Finally, the cool thing will be that I'm also asking you to create some plot, this kind of plots, right? So I tell you how you can draw things with this framework. You go up here and produce something. It won't be like this, but it will be a basic demonstration for this. We will be pretty much close to what is here. So indeed, you have something to start with. I create this repository, creating what is called in the GPTScript jargon a tool. There are a lot of nice documentation and video on the basics of GPTScript. I let you in the description all the link where you can see how it works. But all in all, what GPTScript is, it's something that allows you to set up different steps, taking different tools that can you imagine like a bash functions or commands in bash, collect them and tell the AI, in this case will be OpenAI, but again there are a lot of work making other models working as well. Tell the AI, all right, now you know which kind of tools you should use and you understand how they works. Let's put this in practice, and you give the framework a lot of directives, and hopefully it will reproduce step by step and produce an outcome. You pass this to GPTScript, and that's all. You have your results. What we ask here for our use case is essentially we install root for it for this demo. We are going to pass an OpenAI API key, and then we're going to demonstrate this very simple script that is telling, okay, take a tool that are allowing AI to exec some command and also to write some files and output files, and then take everything else from the tools that we are defining in this repository. And which tools we are defining in this repository? Well, simple like that. You take a repo with this form wherein tool GPT is basically the main function, if you want, where you define your tools. So I'm telling export all the functions that I'm writing in the tools folder and name this big tool collection like our data frame. And this is a tool. I'm explaining this to the AI, sorry, do analysis using this particular framework and create some plots. So whenever I'm going to ask the AI to import this tool and draw something or do some analysis, it will know how to look, where to look, especially. So it will look to whatever modules I teach the AI to use. So let's say, for example, the initialization part. Whenever I tell, okay, OpenAI, initialize, put in a Python script the initialization for my libraries, it will know that it should take this command and the path for the libraries that I should pass and put it in this place and do this dump of the code. Same here, you start to understand how it works, right? So I can tell loaddf is the function that you should look at whenever I ask you to load a branch for a file into an R data frame and take this information and put them into this simple code. And so on and so forth. What we are going to do at the end of the story is write GPTScript, write a Python script for me that contains the following blocks. Make them one after the other, and the first one will be importing root and enable multithreading. The other one will be loading my input data, that are the one that CERN open data, in particular from the CMS experiment. Take this data and start working on that. And yeah, put that into an R data frame named xdf. Then you know also how to select 4 means. Yeah, so select these 4 good means with all the best practices and produce some Z-boson candidates. Eventually, you have also code to draw an histogram. So I'm in my library, in my tool, in this tool that I simply put into this repository, I also teach the AI how to create an histogram starting from a data frame. You see that this is done for LHC experiment for CERN Open Data, but it's really generally applicable. It's really generally applicable to all data science workflows, basically. The same reasoning is behind that. So you start all the modules to be composed to do that analysis. All right, so let's see how it works in practice. I'm going to GPTScript, example RDF. Okay, here I have my all my tools, and let's take a look to one by one. So the initial RDF, I already told you how it works. I'm telling, okay, the only argument that it takes is the X header path, and it will be putting that into the correct position in my code. Then there is the loaddf, where I'm loading my data frame. Then I'm selecting, for example, I'm filtering my meons with all the stuff that we saw before. I'm creating the 4 meon system, so I'm calculating the invariant mass in this case. And again, then I create a function where I tell, okay, whenever I ask you to plot an histogram in 1D of an object in a data frame with n bins, starting from min to max, and store the image in something, do the following: append to my script, to my Python script, these commands. And you know how it works now. So you can increase the library for your analysis as much as you want until you will eventually arrive and you will enable any user, any additional user that comes after you, that comes after, to ask OpenAI or the AI in general and telling in natural language which is the kind of analysis he wants to do. This is crazy. I mean, if the risk is that this will be the way that we envision analysis in the future, probably, right? So a pool of experts maintaining these modules and all other people asking AI or doing it manually, both ways are open to compose these building blocks as they wish. So yeah, let's see how it works and if we can manage to do what we need to do. So I told you before that I had to import my OpenAI key, and then I need to do a GPTScript. Oh, first of all, we install GPTScript. This is what it takes to install the tool. Okay, this is a new version. I can clear this on. I can tell GPTScript do my example. So example, as I mentioned before, got this content, right? Do these steps for me. I let the reference for the RDF GPTScript for this tool. I let you the reference in the description, but there is also an handy web page where I can put the name of the tool and you can document whatever all these tools can do. Here it's very basic, it's in a simple example, but it just worked. So let's say GPTScript example.gpt. Now you start seeing AI calling function one after the others, creating eventually a script that should work out of the way, out of the box. So I'm on purpose asking the GPTScript just to produce the script.py so we can take a look at what has been produced and then execute them and see execute it and see the results. Right, go, and put it do not disturb. Sorry about that. So yeah, it will take a bit. Oh no, sorry, I got confused. In this example, I'm also creating the execution of the script. So essentially, it will run the command, just run the analysis, and produce a plot.png. So, oops. Now locally, I should have, yeah, exactly, a script.py and plot. So let's open script.py, and you see that we have a root installed here, implicit and whatever and blah 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 already installed. That probably, hopefully, should work. Then we have events correctly loaded from the file that we asked, and all the filters, the plot, and eventually the save. So it worked. And okay. Open, and here it is. These are the Muon PT. Let me check if it's exactly what we asked for. Yeah, we ask for exactly for mu pt in the XDF after the selection. So yeah, it worked. I mean, yeah, it's very basic. I promise I should go ahead and see if it can perform more complicated stuff, infer something, instead of having everything served from examples. But even with simply composing examples, it's very powerful because will enable user with no knowledge or little knowledge of Python and the internal of the frameworks to leverage pre-built components and reuse them as they wish. So concentrating really on doing physics and doing science on the results if you want. You can integrate this also with distributed computing frameworks. This will also be cool. And yeah, I'm really curious to see how this will evolve, and yeah, I hope you too. And if you're interested, just join the community or reach out to me and let me know in the comments what you think about that. So thank you for watching. See you next time.